Okay guys, before I move on to section 5.3, but we'll talk about this tomorrow in class, I made a little mistake on part 2 for 5.3. I accidentally, when I moved that 2/3 over here, I made it a 1/2, and I completed the problem as if this was a 1/2. Now this is the correct answer if this was a 1/2. If it's not, then it makes a little bit of difference in how this problem works out. We'll do it tomorrow in class. I'm not going to redo it because this video is for section 5.5. All right, so section 5.5, it can get a little bit complicated, so you need to stay focused. All right, the properties of logs and exponentials, there's two of them. Either you change to, the first property is you change it to an exponential and then you get a common base, and then you are able to set x equals to y and then solve. But what if you can't have a common base? What if there's a problem that there's no way for you to figure out a common base? So at that point, what you do is you use a common log and try to cancel out the logs and use the properties of logs to solve it. Okay, so we use the log properties in these videos to solve. All right, so here's an example. 1/3 to the x equals 6. There's no way, no matter how you think about it, it is impossible to find a common log between 1/3 and 6. So I like using ln, log base e, just because it's easier to write down. But you could use common log or log base 2 on both sides, but I'm going to use ln in most of my examples. Before we move on, we have to look at, this is two parts. First, you have to find the exact form, and then second, you need to round it to the nearest thousands. So there's two parts in this. This part right here, you're going to use the calculator after you find the exact form. So this will sound a little bit tricky, so stick with me. So basically what I'm going to do is I'm just going to set both of these using ln. So I'm going to say ln of 1/3 raised to the x is equal to ln of 6. So because I multiplied both sides by ln, I technically did not change the problem, because what I did to one side, I did to the next side. But now what I'm able to do is use the power property to bring down that x. So I can set this as x times ln of 1/3 equals ln of 6. And now that I did that, I can get the x by itself. Because this is multiplication, I can divide this side by ln of 1/3, and I can divide this side by ln of 1/3. So x is equal to ln of 6 divided by ln of 1/3. So this is the exact solution. Okay, this is not rounded, because remember, log base e, or ln of 6, is a number. We have to figure out what that number is. So now to find the approximate, I'm going to use my calculator. All right, so ignore what's on top. So all I'm going to do is I'm going to plug in ln, oops, I have to control ln of 6 divided by ln of 1/3. And the answer is negative 1.63 negative 1.6309. I need to round it to the nearest thousand, so it's negative 1.631. So this is the approximate. And that's it. All right. Some of them do get a little bit more complicated than the others, but this is basically the method that we use. So again, common base, impossible. So what I'm going to do is I'm going to set ln of 2 raised to the x plus 3 equals ln of 5 raised to the x. And again, I'm going to use the power property. But please remember that when you're bringing this down, you still have to follow the rules of math and multiply out. So this ends up being x plus 3 times ln of 2 equals x times ln of 5. So I need to get x by itself on one side, but before I do that, anytime you have a binomial multiplied by something, you have to distribute. So this x gets this ln of 2, gets distributed to both of these. So this becomes x times ln of 2 plus 3 times ln of 2. Because remember, ln of 2 is just a number. Okay, it's the approximate number. So the approximate number of ln of 2 is 0.693, but we want the exact answer. And then this equals x times ln of 5. So now I notice that I have an x with this guy and an x with that. So I want to put these guys together on one side, and you'll see why in a minute. So this is 3 ln of 2 equals x ln of 5 minus x ln of 2. I just moved that over to this side by subtracting. So now what I'm able to do is 3 ln of 2 is equal, I have a common factor here. What is the common factor between these two? It's going to be just the x. So we're left with x times ln of 5 times ln of 2. And now I can get x by itself by dividing this whole side by ln of 5 minus ln of 2. And I'm dividing this side by ln of 5 minus ln of 2. That cancels out. So my final answer is x equals 3 ln of 2 divided by ln of 5 minus ln of 2. This is my exact. Okay, not rounded. So to figure out my approximate, I need my calculator. So I get my calculator and I plug in exactly what I see right here. So 3 ln of 2, okay, and I'm going to divide that by, put parenthesis, ln of 5 minus ln of 2. Oops. All right. So my exact answer is 2.26941. I need to round that to the nearest thousandths. So it's 2.269. So x is 2.269. There's my approximate. Okay. Now, something funny is going to happen here, but it's going to be to our benefit, and you'll notice in a minute. So again, can't get a common base between e and 3. So what I'm going to do is I'm going to use ln again. So ln of e raised to 0.5 to the x equals ln of 3, 1 minus 2x. Before I bring this down, ln of e, if you remember, is the same thing as saying log base e to e. And anytime you have a base that is the same as this number right here, then the answer, if you remember from our properties, is just going to be k. So this actually ends up turning into a 1, and this guy just comes down, and we're left with 0.5x equals ln of 3, 1 minus 2x. And now I can continue just like I was doing, using the power property to bring this down. So we have 0.5x equals 1 minus 2x in parentheses times ln of 3. And now again, I'm going to distribute this. So 0.5x equals ln of 3 times 1, which is just ln of 3, ln of 3 times negative 2x, which is just 2x ln of 3. So I noticed that this guy right here has an x, and this guy has an x. So I'm going to put them together. I'm going to bring this over here. So 0.5x plus 2x ln of 3 equals ln of 3. So we have a common factor of x. So this ends up being x times 0.5 plus 2 ln of 3 equals ln of 3. And now I can get the x by itself by dividing by 0.5 plus 2 ln of 3. Divide by 0.5 plus 2 ln of 3. So x is equal to ln of 3 divided by 0.5 plus 2 ln of 3. This is my exact. And now to find the approximate, I'm going to use my calc. Oops, sorry. Forget that. I zoomed in a little bit so you guys can't see the whole entire thing. So in my calculator, I'm going to plug in ln of 3. And remember, you could use the control divide button and do ln of 3 on top, and then 0.5 plus 2 ln of 3. And there's my answer, 0.407. So x equals 0.407, and that is my approximate. Okay, moving on to number 4. Number 4 is a little bit funkier, but shouldn't be that much harder. The first thing we got to do is get rid of this 1, because I can just move it over and make this guy a 6. So that's what I'm going to do. I'm going to do 5 times 1.2 raised to 3x minus 2 equals 6. I just moved over this 1, subtract 1, subtract 1. Alright, now I'm going to use the, because these two are being multiplied, I need to split them up, because I can't just bring this 3x in front of this. It's not going to make any sense, because that 3x minus 2 just belongs to that 1.2. So I'm literally going to break this up into ln of 5 plus ln of 1.2 raised to 3x minus 2 equals ln of 6. And now I can use the power property and bring this down. So this becomes ln of 5 plus 3x minus 2 times ln of 1.2 equals ln of 6. Again, same rule. Distribute that ln of 1.2 to both of these guys. So ln of 5 plus 3x ln of 1.2 minus 2 ln of 1.2 equals ln of 6. Okay, so now I need to get this x term by itself. There's no other x term here, so I just need to get this by itself on one side. So I'm going to subtract this ln of 5, and I'm going to add this ln of 2 to the ln of 6. So this becomes 3x ln of 1.2 equals ln of 6 minus ln of 5 plus 2 ln of 1.2. So all I did was I moved this over by subtracting because it's positive, and I moved this guy over by adding. All right, it seems like the problem's getting longer, but we are actually getting closer to the end. Okay. So now I need to get this x by itself. So there is one thing that I can do here to make my life just a little bit easier. If you spot this right off the bat, it's fine. If you don't, you can just continue. You're still going to end up with the same exact answer. So this ln of 6 and this ln of 5, there's nothing in front of them, and they're just being subtracted. So I can use the quotient property, because this is subtraction, and I can change that to 3x ln of 1.2 equals ln of 6 over 5 plus, of course, 2 ln of 1.2. If you know your math enough, you know that 6 divided by 5 is actually just 1.2. Even without a calculator, you can figure that out. Okay, so this ends up being 3x ln of 1.2 equals ln of 1.2 plus 2 ln of 1.2. So at this point, what you could do is there is a common factor here. So I can pull out the common factor, but even if you don't notice that, it's fine. What I'm going to do is I'm going to divide everything by ln of 1.2. Now remember, because there's a plus here, I'm going to divide this guy by ln of 1.2 and this guy by ln of 1.2. So what actually ends up happening is this cleans up beautifully. That is gone. We're left with 3x. This cancels out, but because everything cancels out, remember, it turns into a 1 plus. And then this turns into a 1, and 2 times 1 is just 2. And that's all I'm left with. And now I can solve it. 3x equals 3, divide by 3, divide by 3, x equals 1. I mean, and this is just, it's both the exact and the approximate. There's no way, there's no approximate. That's as low as it's going to get. There's no logs. There isn't any additional part to the problem. All right, we're done. All right, next up. So this part, solve each logarithmic equation. So what's different here is we now have logs in the problem. So we're going to use the similar tactic, but we're actually, instead of setting them up with ln's, we're going to set them up with the common base that's in the log. So natural log, what is the base of natural log? It's e. So I'm literally going to do e, raise that to ln of 2x, and e raised to 5. So because I'm doing this to both sides, I'm not changing the problem. I'm just using something so that I can easily solve this. Now you guys know from the properties that e raised to log base e ends up equaling whatever is left over. Remember your k. So this is just 2x equals e to the 5th. And now I can solve for x. Divide by 2, divide by 2. So x is e to the 5th divided by 2. So this is my exact. And of course, how do you find your approximate? Calculator. So I'm sure you guys have guessed that you're probably going to have a calculator portion on this test, and this is what it's going to be. So e to the 5 is 148.413. Divide that by 2, you get 74.207. So that is my approximate. Not very difficult. So here's ln. What is the base of ln? It's e. So I'm going to take e. I'm going to raise this whole thing to 1 minus x equals e raised to the 1/2. Again, e raised to ln ends up equaling whatever that is. So that is gone, and you're left with 1 minus x is equal to e to the 1/2. And now we want to solve for x, so we subtract 1, subtract 1. And then divide by -1. And you remember, you divide everything by -1 because there's a minus sign. So this is x equals negative e to the 1/2 plus 1. So you can keep it like this, or you can rewrite it to make it prettier by doing e to the 1/2. And if you remember, e to the 1/2 is the same thing as saying 1 minus the square root of e. So this is the exact solution. And then the approximate solution is going to be 1 minus the square root of e. Which is negative 0.6487, so 0.649. So x equals negative 0.649. And that is your approximate. All right, number 7. All right, before we do anything with number 7, we need to clean this up. The only way that this is going to work is if you actually have I don't want to say one log, because you'll notice in the next problem you will end up having 2 different logs, but at least a log where you can separate them on both sides. So we know from the properties that because this is addition, we can combine them into one using multiplication. And now this becomes log 3x squared minus 13x equals 1. So what is the base of this log? The base of this log is 10, so I'm literally going to use that as the base of my exponential. So 10 raised to this whole entire thing equals 10 raised to 1. Remember, what you do on one side, you have to do on the other side, or else you're changing the whole entire equation. So because this is 10 raised to log base 10, then the answer to this side of the equation is just whatever your k value is, which is 3x squared minus 13x. And that equals 10 to the 1, which is just 10. And now you solve it. And remember, because this is quadratic, the only way that you can solve it is to factor. So 3x squared minus 13x minus 10 equals 0. So when you factor this, I'm not going to do the whole entire box method, but remember, you multiply a times c, so this is negative 30. This is negative 13, your b term. What are 2 numbers that multiply to negative 30 and at the same time add to negative 13? And that is going to be negative 15 and positive 2. All right, maybe I am going to do the whole box method. And then, of course, in your box, first term, first box, last term, last box, and then your 2 factors go here. find the GCF of each row and each column. So this ends up being x minus 5, and then 3x plus 2. So my factors are 3x plus 2 and x minus 5. You solve that, x equals negative 2/3 and x equals 5. Now by definition of a log, you can't, logs can't be negative. You can't plug in a negative in for x because log of a negative is not going to work, because 10 raised to anything will never give you a negative. If you are 10 raised to what is going to give you a negative 2/3? Nothing. So that can't be the answer. So our answer is just x equals 5. And again, this is your exact, technically your approximate too. All right, and if you plug this in, it will work. It will give you 1. All right, and I'm going to show you that actually, just to show that it works and why log of negative, oops, I don't know why that happened. So log 10 of negative 2 divided by 3, you get an error. It's a non-real calculation, so that's impossible. It's not going to work. But if you do log, and the problem here is log base 10 of 5 plus log base 10 of 3 times 5 minus 13, and you get 1, so it checks out. All right, this last problem, basically what I'm going to do is I want to move these two to this side of the equation. The reason why is once I move them, they become, both of them, they become pluses, and I'm able to combine them using the power property. So we end up with ln of 5 plus 4x on this side, and on this side you have ln of 3 plus x plus ln of 3. So because these two are added, I can combine them into ln of 3 times 3 plus x. And then when we clean this up, we get ln of 5 plus 4x equals ln of 9 plus 3x. And now because we have ln on this side and ln on this side, then basically I can use the base, which is e, for both. So e to the ln of 5 plus 4x equals e to the ln of 9 plus 3x. And guess what happens to e to the ln? They're gone, because my answer is just going to be my k, which is 5 plus 4x, equals 9 plus 3x. And then we just solve. So we subtract 5 from this side and this side. You have 4x equals 4 plus 3x minus 3x minus 3x. So x is 4. Done. And then you can check it by plugging it back in to make sure that it equals 0. And I assure you it does. All right, so I know this section was a little bit tough. There's a lot to think about while you're doing those problems, which means please practice these problems. This section 5.5 is just the one that requires a little bit more thinking while you are writing things out. All right, thank you.